All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? How's the long weekend? Good? Yeah? All right. So our warm-up number 47 is on the screen. Number 1, it says simplify and round your answer to the nearest tenth. We have square root of 20. Now, I'll go over number 1 at the end. But the next 3 you should be able to do by yourself. Number 2 says graph f of x equals x cubed without a table. Then write the rule and graph the transformation if g of x equals a times f of, parentheses, 1 over bx minus h, close parentheses, plus k. The parameters given are a equals 1, b equals 1, h equals 2, and k equals 5. Number 3 says solve by completing the square and allow for imaginary numbers. They give us the quadratic equation x squared minus 8x plus 20 equals y. And number 4 reads compute the voltage for the inductor of the electric circuit. And they give you a diagram. Make sure you copy the diagram. And given that the current amps is 24 plus 12i. So make sure you use that as part of your formula and compute the voltage going through the inductor. I'll give you some time once again, and I'll get started right after you are almost completed. Ready and go. All right, here we go. So I'm going to start with number 4, then I'm going to go to number 3, and so on and so forth. And I'll leave number 1 till the end. So number 4, let me create some space here. All right, it says, compute the voltage of the inductor. So by now, you guys should know that the inductor is the one that looks like this. Like if you're twirling a wire around something, yes? So we need our formula. The formula is V equals capital I for current times Z, which is the impedance. So if this is 3 ohms, the impedance is 3I. The current given is right here, 24 plus 12I. We're going to distribute the 3I to multiply that. That's going to give us our voltage. So let's see, distribute. So we end up with V equals 3I times 24, that's 72I. 3I times 12I, that's positive 36I squared. We're not done because we have an I squared. What do we do there? Substitute a -1. So when we substitute a -1, we re-simplify. So what is -1 times 36? That's -36. Bring down the positive 72I. And that is the voltage going through the inductor of that circuit. All right. All right, over here on the left side, I'm going to go ahead and do number 3. Number 3 reads solve by completing the square, allow for imaginary numbers. And our equation is x squared minus 8x plus 20 equals y. So therefore, I need it in standard form. So x squared minus 8x minus 8x plus 20 equals to 0. Next step, divide by the leading coefficient, which is 1. So I end up with x squared minus 8x plus 20 equals to 0. Next, get rid of the constant. What is my constant? The 20. So I subtract 20, We get x squared minus 8x space equals to -20. Complete the square. How do we complete the square on the left side? So we take -8 divided by 2 squared, and we do that to both sides. -8 divided by 2 squared. All right, so therefore, let's simplify this. This is x squared minus 8x. -8 divided by 2 is -4 squared. That's 16 equals to -20 plus 16. I can simplify the right side. That gives me -4. And the left side still x squared minus 8x plus 16. All right, now I need to factor the left side. How do I do that? Use a shortcut since it's a perfect square trinomial. So square root of the first, square root of the last, which is 16, that's 4. Sign of the middle, which is a minus, squared equals to -4. All right, next. To get rid of that square, I take the square root of the left. What do I do to one side, do to the other? We're left with x minus 4 equals plus minus. What is square root of negative 4? Square root of negative 4 is what?
2i.
2i, thank you. All right, and then we're going to solve for x, so we add 4, add 4. We end up with x equals 4 plus minus 2i. So my two solutions or equations at the end is x sub 1, which is 4 plus 2i, and x sub 2 is 4 minus 2i. What kind of solutions are those? These are non-real because of the imaginary. That's why these are known as what? Imaginary solutions. Imaginary. We good so far? Yeah. So that was numbers 3 and number 4 with the voltage. Okay. Let's go to number 2. Now, guys, for those of you that are not doing your warm up and you're not following with your practice, some of you are missing out on a lot of stuff that is needed for the following sessions that are coming, especially now that we're coming back again to transformations. So I don't know how else to say it, but you need to do your home play and your warm up and all the components of this class, guys. You need to be on top of those, or else you're going to be missing out of a bunch of practice. Okay. All right. So let me go over number 2. Number 2, it says graph f of x equals x cubed without a table. So let me get my coordinate plane. Do that right here. Here's my x and my f of x. And what do I need to graph without a table? So I need the domain being -1, -2, 1, 2, and 0. Okay. So what do I do to -2? It says here x cubed. That means I'm going to cube it. That means times itself 3 times. So -2 times -2 times -2 is -8, which is down here. I put -8, -2, -8. There it is. Next one, -1 cubed, -1 times -1, 1 times -1 is -1, which is about right there. I'm going to place the point right there, -1, -1, 0, 0. What is 1 cubed? 1 times 1 times 1 is still 1. And 2 times 2 times 2, that is 8, which is somewhere up here, 8. So this is my cubic function. Oh, hold on. It looked kind of funky. Where's the trash can? Where are you, trash can? Oh, just place it there. Okay. So my cubic function is right there. Okay, there it is. All right. So they want us to write a transformation given those parameters. So let me substitute really quick into what was given, the general form. So A is 1, B is 1, H is 2, K is 5. So let me rewrite this. G of x equals 1 times f, parentheses, 1 over 1x minus 2. And outside the parentheses, I'm going to write what? Cube, because it's a cubic function now, plus 5. All right, let me simplify that one more time. I'll do the next one in red. So I write g of x equals, I don't need the 1 or the f anymore. So parentheses, 1 over 1 is still x minus 2 cubed plus 5. So out of all the parameters that they gave us, if you notice, A is, since it's a 1, we don't write it. It's invisible. B, since it was 1 over 1, it's 1, and we don't write it either. So what is the ones that we see? We see H and we see K. H is going to take us to the right. K is going to take us up. Okay, now check this out. I said, and I've been saying on the warm-up, said now we're going to focus on this point right here, the point 0, 0. Let's call it the vertex for right now. The point 0, 0 right here, guys, I'm going to move it according to H and K. So I'm going to go 2 to the right and 5 up, this 0, 0. So I'm going to go 2 to the right, 5 up. So it's going to be somewhere around right there. 2 to the right, 5 up. So now that point is at 2, 5. So that means if I bring all the other points over, the new transformed function is going to look something like this. It moved to the right and up. But this point, the 0, 0, now became what? 2, 5. Where did we get 2, 5 from? Yeah, from H and from K. All right? All right, just want to make sure we're staying on top of this because, like I said, we're about to get into the new transformations that are coming up with the new functions, okay? And the last one, number 1. It reads, let me make some space here. Oh, what was that? Okay, there it is. It says, simplify and round your answer to the nearest tenth. Let me repeat that again. Simplify and round to the nearest tenth. That means we're going to need a decimal equivalent. So here goes the process. Ready? I kind of covered this already sometime back. I just did a quick introduction. Those of you that have been with me before, you should know how to do this, but here it goes again. They want us to find the square root of 20. So I'm thinking about the number 20. The number 20 has to fall between 2 perfect square numbers. What are my perfect squares? Well, perfect squares is 1, 4, 9, 16, 25, 36, 49, 64, and so on and so forth. Where are you getting those numbers, Mr. Q? Well, what is 1 squared? 1. What is 2 squared? 4. 3 squared? 9. 4 squared? 16, and so on and so forth. These numbers on top, they're known as perfect square numbers because we can take the square root of those numbers. So question, between what 2 perfect square numbers is 20 found? Between what 2 numbers can I put 20? Between what? Yeah, between 16 and 25. So 20 would fit somewhere right here. Is that correct? So check this out. So if I took the square root of 16, that is 4. Square root of 25 is 5. That means the square root of 20 has to be approximately 4 point something. Is that correct? Because square root of 16 is 4. Square root of 25 is 5. Square root of 20, since it's in between, it has to be 4 point something. Let's find that decimal form. And here goes, how do you find it? Here it goes. Take the middle number, subtract it from the smaller number. What is 20 minus 16? That is 4. Take the large number, subtract it from the smaller number. What is 25 minus 16? That is 9. Once you have a fraction, you can do the division. Does not fit in there, add a 0. Fits in there 4 times, that's 36. Subtract 4, add another 0, and what do we notice? It's going to repeat, but they want it to the nearest what? 10th. So this is 100th, this is 10th. Does this go up to a 5? Does it stay a 4? Stays a 4 because this one's not a 5, so this would be approximately 4.4. This is approximately 4.4. Make sure you get this because this is what you're going to be doing on tonight's home play, okay? So for answers, I don't want a square root number. I want it in what? Decimal form to the nearest 10th. All right, that was good, yeah? All right, let's move on. So our agenda for today, warm-up number 47, we just finished. Today we're going to be talking about the distance formula. That's what we're going to use for our home plate. And you're going to have 10 problems to solve for tonight, 10 problems only. Once again, warm-up number 47, distance formula, home place 10 problems only. Okay, and reminder, if you need support, make sure to come right after lunch for tutoring. It is free. My goodness. All right, your asynchronous code is HJYDL. 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 That's your asynchronous code. You're going to need it because that's where you're going to get your home plate from. Now, over the weekend, you had for home play the play sheet 9.7C, which was a practice on completing the square. Is that correct? Yes, Mr. Q. Now, why am I giving you so much practice on completing the square? Because on Thursday, when we move on to the next function and transformations and graphing, you need to know this process very well. It has to be like so automatic that right now you wake up and, oh, I'm completing the square. That's how you wake up. Right? Am I right, Giselle? Yeah? Okay, good. Yeah. All right. Once again, your home play for tonight is 10 problems. There they are. Your play sheet from the weekend you should have turned in on Canvas. Make sure you turn it in on Canvas. Those are the 10 problems. And the 10 problems on screen show, use the distance formula to compute the distance between the points. What are we going to use? The distance formula. But look at the next part. It says, round to the nearest tenth if needed. What does that mean? That you need to do what we just did on the warm-up problem number 1. And here are the 10 problems. 1, we have 2 points, 2, 3, and 6, 7. Number 2, the 2 points are 0, 0, and 3, 4. Number 3, 0, 0, and negative 9, negative 12. Number 4, 1, negative 2, and negative 4, 4. Number 5, 0, 5, and 7, 5. Number 6, negative 5, 0, and 0, 0. Number 7, 1, 1, and negative 4, 4. Number 8, 1, negative 2, and 4, 4. Number 9, 1, negative 1, and negative 3, 4. And number 10, 4, 0, and 0, negative 3. That's your home plate for tonight. Make sure stay on top of it. You're going to need it. Here we go. All right, our objective for today, I can derive the distance formula and compute the distance between 2 points. I can derive the distance formula and compute the distance between 2 points. So today we're going to do 2 things. We're going to derive the distance formula. What does that mean, Mr. Q? That I'm going to show you where it comes from. We're going to bring it from somewhere. It's not just like, oh, this is the distance formula, you need to learn it. Yes, that is true, but I like to find out where everything comes from, so I'm going to show you where it comes from. And then we're going to compute the distance between 2 points using the distance formula, okay? So before we get started with distance formula, I'm going to take you back to middle school. And I'm pretty sure your teacher, I hope they did, they introduced you to the Pythagorean Theorem. Let's go. Who remembers that? Yeah? All right. Now, for those of you that weren't with me, those of you that were, I introduced it with giving you the little story behind Pythagoras. The mathematician that came up with this theorem, his name was Pythagoras of Samos. It's an island, a Greek island, and he was a well-known mathematician. Now, let me put it to you in this way. Let me wrap your brain around those days. Those days there were kings and queens, okay? And in those days there was always there were like invaders and fighting for territories and such like that. So let's imagine that we live in this territory here, which is the Imperial Kingdom. Bam, that sounds pretty good, right? The Imperial Kingdom, yeah? So, and in this kingdom, there was a mathematician known as Q Pythagoras. Let's go. So he was well known. And he had some informants tell him that there were going to be some invaders coming to the kingdom. So he approaches his queen. So he's Queen Mia. Queen Mia, this is Q Pythagoras. And I was informed that we're going to get invaders here in our imperial kingdom. And she's like, okay, so do what you have to do in order for us to prepare. I'm like, all right. So Q Pythagoras says, you know what? I'm going to send a scout. Let's see. Scout Michael, grab a horse and ride all the way to San Diego. Nonstop. Don't even stop for burritos or anything. All the way through. And when you get to the point of the beach where all the invaders are arriving, I want you to hide and I want you to count how many steps they take when they march in 10 seconds. So he's like, okay. So then he hides, he gets there, and then he's hiding, and then he starts to count 1 Mississippi, 2 Mississippi. Oh, wait a minute. There's no Mississippi back then. 1 Hopeville, 2 Hopeville, 3 Hopeville. So he's counting the seconds. He counts the steps. He gets back on the horse, gets back. He arrives all tired, no burritos. So then he gets, and then he's all, cue Pythagoras, this is how many steps, and this is how much they did in 10 seconds. I'm all, thank you. So then cue Pythagoras gets his tools and starts computing and goes, Queen Mia, the invaders are gonna get here in 3.5 days. So we need to make sure that there's a perimeter around our kingdom so that they don't take our burgers from Farmer Boys and all those places. So we need to prepare. So do what you must. So then I say, all right. So I get all my peons, which is all of you, and I say, okay, guys, so get your horse and get one of those hay, a bale of hay, take it with you, and I give each one of you one. Angie, also take one. Anthony, you take one. Daniel, Danny, Jeremy, and so on and so forth. Everybody, we're going to create a perimeter around the Imperial Kingdom. Okay, and make sure we stack as much as we can, so like that, when they get here, they are met with that fortress. Long story short, we won. You know, we were able to deter the invaders. They didn't get our burgers, and they left. However, time passed, and Queen Mia fell in love and got herself a king. And the king started getting ideas in her noodle and said, you know what? You better get rid of that guy, Q Pythagoras, because he's a wizard. How did he figure out that they were going to come in 3.5 days? So she's all, bruh, that's true. So she sent out a group to try and assassinate Q Pythagoras, but I was too quick. I zipped and I zagged and I got out of here. But I said, you know what? I'm going to leave, but I'm going to leave all my teachings to people so like that they at least know how to create mathematics. And this is what he did. Ready? Pay attention to this part. Take the first prime number. Double it. Now take that new number and square it. Okay? If you know what number I have right now, unmute yourself and say the number we're at. What? I didn't hear you.
1.
Nope. All right. So what I just did, I did a mental math because back then he was going to convey all his teachings to people without taking any notes, or else people were going to get killed. So that's how he would go from town to town, giving his information to other mathematicians. Those mathematicians that actually got it. So the first prime number is 2, double that, that's 4, square it, that's 4 times 4 is 16. Only those that knew how to follow along doing mental math were the ones that were going to be part of the Pythagoreans. The Pythagoreans, the way that we're going to know one another is by a medallion. Look at the medallion. Bam, let's go. So Pythagoras came up with a theorem, and let's see if you guys remember, that related these two legs, this one and this one. And the way he did it, he said, well, let me start with area. So let's see, I do this here and this here in order to get this here. Does anybody see the relation? Unmute yourself and see if you see the relation. This to this. Who sees a relation? Yeah? You guys see it? No? All right, let me make it a little bit more obvious. Here it goes. So he started saying, well, if this is a right triangle and this is only going to work with that, he saw a pattern. If this measures 3, this is 9 squares. This measures 4, this is 16 squares. This measures 5. This is 25 squares. And he saw a pattern for me. Does everybody see it now? Is there a relation? Yeah? Yeah. 9 plus 16 equals to 25. Where did we get 9? Well, it's 3 times 3, or 3 squared, plus 4 times 4, which is 4 squared, which is 5 times 5, or 5 squared. And this is what we know as a squared plus b squared equals c squared. And that's where we get our Pythagorean theorem. You guys remember that now? Yeah? Kind of? All right. Morning. So I just wanted to bring this back again, guys, give you guys the quick introduction. We're going to need this for the distance formula. So here we go. Example 1 mega cube. Copy this, please. I'm sorry, 1 cube. Copy this right triangle. The legs measure 8 centimeters and 15 centimeters, and the longest side, label it C. Copy that, and we're going to do that using, solve for the missing length using the Pythagorean theorem. 20 seconds, copy that. All right, so let's see. So we know that one of these has to be A and B. It doesn't matter which. I'm going to label this one A, this one B. It doesn't matter. This one's C. So let's get our Pythagorean theorem. A squared plus B squared equals C squared. So A is 15 squared, B is 8 squared, and C is still C squared. So what is 15 squared? That's 225 plus 8 times 8 is 64, which is C squared. 225 plus 64, that's 289 equals C squared. And how do we get rid of this square right here? We take the square root. The square root is cancels this. So therefore C is, for the sake of time, square root of 289 is 17. Now, do we leave it like that? Nope. At the end, we need a unit of measure. In this case, they gave us centimeters, so 17 is what? C is 17 centimeters. That's the measurement of the longest side. Are we there so far? Okay. Now, just to clarify something really quick before I give you one to do by yourself, watch. You don't have to copy this part, but this is just to clarify. If I was to rewrite this again, A squared plus B squared equals C squared. But now I have values. I have 15 squared plus 8 squared equals 17 squared. Now check this out. If I wanted to use some inverse operations, and I wanted to get rid of this squared right here, what would I do? Yeah, take the square root. That cancels that, but watch. If I did the same thing to the other side and I cancel the squares, I would end up with 15 plus 8 equals 17. So let's see, what is 15 plus 8? 23. Is 23 equal to 17? No. Did everybody follow? If I want to get rid of this square right here, I can do the square here because it's only one number with a squared. I can take the square root. But when I take the square root over here, this one's not going to be able to take the squares from each one of these because there's this sum in between. So what do we do, Mr. Q? So that means that I can do it to this side, but not to these. So that means these will stay with a square root like this. So I go from here to here, which is square root of 225 plus 64, which is equal to 17. This is 289 square root, which is 17. And we know that this is true because that's what we got over here. So I just wanted to give you this in passing. Whenever you have a plus in between two squares, you cannot take the squares away with a square root, okay? All right, I want you to do one by yourself. Copy this next one, please. Example 1 super cube. Copy that triangle. It's a right triangle with the legs 30 feet and 40 feet. Find me the distance of C. Copy and go. All right, let's see what we got. Well, we should have read our Pythagorean theorem, which is A squared plus B squared equals C squared.
Is it 50?
Yeah. What's that?
Is C equal to 60 centimeters? Feet?
Let's find out. This is 40 squared, which equals to C squared. This is 900 plus 1600 equals to C squared. This is 2500 equals to C squared. Square root, 50 equals C. So this is 50 feet. Hands if you got that. Okay. So is the Pythagorean theorem coming back? Yes. All right, so we know how to use the Pythagorean theorem using a right triangle. So now I'm going to give you 2 points that we're going to plot on a coordinate plane and use the Pythagorean theorem to find the distance between the points. Okay, so here we go. Copy this, please. Create a coordinate plane, label it from -10 to 10. Once again, make sure you're using your graphing notebook. And it reads, example 1 mega cube. Compute the distance between the points 2, 8 and 4, 4. Now, mind you, right now we're using the Pythagorean theorem, but where I'm heading with this is for the distance formula. And we'll get there in a little bit, but I just want to give you some practice with this. Once again, example 1 mega cube reads, compute the distance between the points 2, 8 and 4, 4. All right, so let's plot those points. Here we go. 2, 8 is about right here, 2, 8. 4, 4 is about right there. So here are my 2 points. And I need to get or compute the distance from this point to that point. Question, do you guys see the triangle? If you write triangle for me, you guys see it? Yes, Mr. Q. All right, in case you don't see it, here, let me show you. Here's a right angle right here. So I need this measurement right here. And I need this distance right there. All right, so if I count the squares down here, guys, we know that it's what? 1, 2. So far, so good? All right. How about this one up here? The distance from here and here we go. 1, 2, 3, 4. However, look up to the screen, please. Look up, look up. I do want to show you something to make sure that your noodle's getting ready. Look up. Look at the bottom number, the 2. I'm going from here, from this distance, from this point, which is the x value for this point. The first point, the x value is 2. And the second point, the x value is 4. So if I was to use those 2 values, how would I end up with 2?
Subtracting.
Subtracting, yeah, 4 minus 2. Now let's look at this number, the number 4. That means this point down here has a y value of 4. This point up here has a y value of 8. And once again, how do we get this 4? Subtracting 8 minus 4. That's how we get that number. I just wanted to show you really quick. So what are we going to compute? We need to find this distance from these 2 points. So let's write our Pythagorean theorem. Here we go. A squared plus B squared equals C squared. So A is 2 squared plus B is 4 squared and C is D squared. Okay, so let's continue. 2 squared is 4, 4 squared is 16, and that is D squared. 4 plus 16 is 20 equals D squared. How do we solve for D, guys?
Using a square root.
Square root. to both sides, we end up with square root of 20 equals to D. But wait a minute. What did I say at the beginning? That I don't want the answer in square root form. I want it in decimal form. How do I find the decimal equivalent of that one? You're like, oh yeah, Mr. Q. I know, right? Reeled you guys in pretty good. Here goes the process one more time. Between what two perfect square numbers is 20 found?
Sixteen and 25.
Yeah, 16 and 25. I'm going to do it over here. 20 is between 16 and 25. So if square root of 16 is 4, square root of 25 is 5, that means this one has to be 4 point something. Is that correct? Okay, so let's find that something. 20 minus 16, that is 4. 25 minus 16, that is 9. Let's do the division. 4 divided by 9 does not fit in there. Add a decimal, add a 0. 4 times 9 is 36. Subtract that 4, add another 0, bring it down. And if we repeat it, it repeats, but we only want it rounded to the nearest tenth. That means to the first 4. Is it going to go up to a 5 or stay at 4? Well, it stays at 4 because this was not a 5. So this is approximately 4.4 units. That's the distance of this segment between those 2 points. 4.4 units approximately. Is it coming back? Yes. Show me your fingers. I'll come to your with these. Yeah. 5, 5, 5, 4. Okay. All right, let's do another one, yeah? Here we go. Get another coordinate plane, label it example Q. Here we go. And for this example, I'm not going to give you the coordinate. I'm actually going to give you the points already plotted on the graph. You should be able to do what we did from there. So example Q. And the points given, let's do 5, 5. Here's a point right there, 5, 5. And 8, 9, 8, 9. 5, 5, and 8, 9. So we need to find this distance D. So before we write our Pythagorean theorem, what distance do we need? Well, do you guys see the triangle forming? Yes, it's right here, Mr. Q. Straight down from here, across from here, my right angle. That means I need this distance, and I need this distance. So what's the distance down here, guys? What is this distance? I see some of you saying 3. And just to confirm, what is the x value for the first point? The x value is 5. What is the x value for the second point? 8. And let's see, what is 8 minus 5? Yep, there it is. It's 3. That is correct. Okay. So what is the distance for this one going upward or downward? Let's see, 1, 2, 3, 4. Yes. And how did we get that? Let's see. The y value for this bottom point is 5. The y value for this top point is 9. So that means 9 minus 5. Does that give us 4? Yes. Okay. So let's use our Pythagorean theorem. A squared plus B squared equals C squared. So we got 3 squared plus 4 squared equals D squared. This is 9 plus 16 equals D squared. 25 equals D squared. And then to solve for D, we take the square root. So 5 equals D. That is in units. How we doing? Yeah? Show me your fingers. I'll come to you with these. 5, 5, 5, 5. Yeah. Like I said, this is more middle school stuff, but the way I'm approaching it, because we're about to get into the distance formula. And I just want to make sure that you're understanding where we got the distance formula. Ready? All right. So now that we're done with that one, I'm gonna give you one now without any numbers. How about them apples? Yeah, let's go. Copy this one. And for this one, I'm not even gonna give you an example. If you wanna call it example Michael Jordan Q, bam. Yeah, that sounds good. Example MJQ. Okay. So we got our X axis and our Y axis. And we're gonna find the distance between this first point and this second point. Distance from here to here. And I'm giving you one point lower and closer to the point of origin, and another point higher and away from the point of origin. Okay. But I'm not going to give you any values. However, what do we know? Look at these 2 points, guys. Which is my first point? Is it this one or this one? The one on the left. Yes, that is correct. So that means this has an X value and it has a Y value. But this one also has an X value and this one also has an Y value. How do we know which one is which? Which one is first? The one from left to right that we encounter first is the first. So how do we know this is our first point?
Because it's smaller in mass.
Yeah, but how would we label it to know that it's the first point?
A.
Or
B.
X sub 1.
X sub 1, Y sub 1. Let's go, Queen Mia. Okay, so that means the second point, what do we label it? That, since it's our second point, X sub 2, Y sub 2. There you go. Okay, now that we have some values, let's draw our triangle right here. Here's a right triangle. We still need this distance in red, the bottom one, and this distance in green. So question, who can give me the distance in red? Jaziel, what would I write? Look at it. Remember on the previous one we had
X2 minus X1.
let's go. X sub 2 minus X sub 1. That is correct. How about this one, Hayden? What do I write here for this distance?
X sub 2 or Y sub 2 minus Y sub 1.
Yeah, Y sub 2 minus Y sub 1. Okay. And we need to figure out this distance, which is D. So check this out. We're going to get the Pythagorean theorem, A squared plus B squared equals C squared. But now I'm going to write parentheses squared plus parentheses squared equals squared, because instead of C, I'm going to substitute D. Instead of A, what am I going to substitute? X sub 2 minus X sub 1. Instead of B, I'm going to substitute what? Y sub 2 minus Y sub 1. But since we're solving for D, I need to take the square root of this side, and whatever I do to one side, I do to the other. But remember, this side, it does cancel the square because it's only D by itself. Can I take the squares away from the other side? No, because there's this sum right here. So the other side stays as a square root of X sub 2 minus X sub 1. Y sub 2 minus Y sub 1. And guys, this is our distance formula. Woo, let's go. You're like, wow, I know, right? So where does the distance formula come from? It comes from the Pythagorean theorem, but without any number values. We use X sub 2, X sub 1 values and Y sub 2, Y sub 1 values to get the distance formula. Okay, so you need to know this formula, guys. Make sure you put it in your noodle. And that's what we're gonna need to find the distance between 2 points without graphing. Let me repeat that again. Your homework for tonight is finding the distance between 2 points without graphing. Distance between 2 points with what? Without graphing. So let's do one together. Y'all ready? Here we go. Copy this one, example number 2. Example number 2 reads, compute the distance between the points 2, 3, and 5, 7. Compute the distance between the points 2, 3, and 5, 7s. Compute the distance between the points 2, 3, and 5, 7s. Compute the distance between the points 2, 3, and 5, 7s. So the first things first, guys, write your formula. D equals square root, parentheses squared, plus parentheses squared. Inside the first parentheses, we have x sub 2 minus x sub 1. The second parentheses is y sub 2 minus y sub 1. I'm going to rewrite it again. Here we go. D equals square root, parentheses squared, plus parentheses squared. Now look up really quick. What's inside here? There's a subtraction sign, so make sure you don't forget these 2 subtraction signs inside the parentheses, because if you do, your computation is going to be wrong. All right, so now we need x sub 2, x sub 1, y sub 2, y sub 1. What do we do?
Input the x's and y's.
Yeah, we need to label first the 2 points. So my first point is x sub 1, y sub 1. The second point is x sub 2, y sub 2. And now we just substitute them in there. So here we go. I'm going to start with x sub 2. X sub 2 is 5. Okay. X sub 1 is 2. Next, y sub 2. What is y sub 2? Y sub 2 is 7. Next one is y sub 1. What is y sub 1? 3. All right, let's simplify. Square root. 5 minus 2, that's 3 squared, plus 4 minus 3, 7 minus 3 is 4 squared. So what is 3 squared? That's 9, plus 4 squared is 16. So D equals square root of 25. How do we get rid of that radical? Square root of 25 is 5 units. You're like, it looks like kind of like what we did with the Pythagorean theorem. Yes, it pretty much, if you think about it, technically is the Pythagorean theorem, but except for on this side, we don't have a squared or square root. The square root is only on the other side. Show me the fingers I'll come to you with these. 5, 5, 5, 4, 5, 4. Okay, let's do another one. So here goes the process one more time. You write your formula. You label your points, x sub 1, y sub 1, x sub 2, y sub 2, substitute into the formula, simplify, and that's how you find your distance, okay? Now, mind you, look up really quick. Some, it's not gonna be perfect like this, square root of 25 is 5. Oh, that was perfect. Some, you're gonna end up with this, D equals square root of 15. So we need decimal. Between what 2 perfect square numbers is that found? Between 9 and 16. So that means that D is going to be approximately between square root of 9, square root of 16, square root of 9 is 3, so it would be 3 point something. How do we find that something? Well, you subtract that minus that, and that minus that. So 6 over 7. 7 fits in there, 8. That's 56, 4, 5. So this is going to be 3.9 approximately. So that's what you need to do on some of those when you don't have the perfect square root at the end. Do this next one by yourself. This will be our last example. Example 2Q, compute the distance between the points 2, 1 and 6, 4. Use the distance formula for that, please. Copy and go. All right, I'm gonna do this one all in black, see if you got something like me. D equals square root of x sub 2 minus x sub 1 squared plus parentheses, y sub 2 minus y sub 1 squared. We label our points x sub 1, y sub 1, x sub 2, y sub 2. So we end up with d equals square root of x sub 2 is 6, x sub 1 is 2, so I'm going to write 6 minus 2 squared plus y sub 2 is 4, y sub 1 is 1, so it's 4 minus 1. So we end up with d equals square root of 4 squared plus 3 squared. And this is d equals square root of 16 plus 9. D equals square root of 25. And what is square root of 25? D equals 5 units. 5 units. Hands, have you got that? Let's go. So once again, your home plate is going to be 10 problems of these. Let's see how you do with the distance formula. Let me bring that up really quick again. Let's see. There it is. Those 10 problems on your screen. Make sure you get to those. If not, with your asynchronous code, make sure you get to those. Tutoring right after lunch if you need support. See you guys there. Be there or be elsewhere. Have a good one, guys. Peace. Bye.
Later, Skew.
Later,
Have a good day.
guys.
Take care.
You too. Bye.